Let's go through the code 1996, the number of weak characters in the game. For this question, it gives us a two-dimensional array properties, and each array property, the element property represent a character, and this array has an attacked value and also a defense value. So there is a definition. A character is said to be weak if there is any other character has both attack and defense level strictly greater than the character's attack and defense level. For example, let's look at this 2, 2, and 3, 3. You see 2 is smaller than 3, and the second 2 is also smaller than 3. So we'll say this one is weaker than 3, 3. So as long as there is a character which is weaker than another one, so we'll say this character counts as one weak character. So we return the number of weak characters. Let's take an example. We'll say this one 4, 3. Let's say this is weaker than 10, 4, right? So so this one return 1. If we have a number, for example, it is 100, 100. This character, we'll say 1, 5, 10, 4, 4, 3. They are all smaller than this one. So we'll consider this, and this ought to be has someone stronger than this one. So this one returns 3. So for this question, it asks that the other character must be has a attack and a defense level strictly greater than. That means if we have a character have 1, 5, another one have 2, 5, we cannot say this one is weaker because they have same value 5. But if we have 2, 6, then we'll say this one is weaker. So how can we do this question? We can the intuitive way is that we can do some kind of sorting those kind of characters. And for example, those kind of character by the attacked value, right? So for example, we have the attack value 1, 1, 1. For the sorting, attack value will be 1, 1, 1, 2, 2, and 6, something like this. This will be the attacked. And we just need to compare the defense value, right? So we'll say for the defense value, if the later one is bigger than previous one. So we have a tricky way to do this because we know for the same attack value, the one which is after this, even this is bigger, we cannot consider the later one to be stronger than previous one. So we can sort the attack value by increasing order and sort the defense value in a decrease value, right? So in this case, for example, we have 1, 9, right? And 1, 7, and 1, 6. And we try, so, for example, here we have 2, 10, 2, 7, right? And then we have 6, 8. So we go through this kind of example. What we thought is 1, 9, 1, 7, 1, 6, 2, 10, 2, 7, and 6, 8, right? So in this case, we just compare the second value. We'll see if there is a value greater than this. Well, we'll say there will have in the right, there will have a character which will be stronger than this. For example, 1, 9. We'll see on the right there is a number greater than 9. We'll say this one, 10, right? 10 is greater than 1. So we'll say on the right, at least there is one character stronger than my current one. So we after this kind of sorting, we just have variable called defense right max. I iterate from the right to left, trying to see compare our current defense value. If this one is greater than this one, we just update the right defense max. If this is smaller, we just add a count. So in the end, we just return a count. So let's begin to write code for this. So we'll say for these properties, we are going to sort. For attacked, we'll have an increasing order. And for defense, that will have the decrease order. And for this kind of tricks, there is another question called Russian dough envelope. It have the same tricks. That is, we need the later one will be strictly greater than previous one. So we have this kind of sort. So we'll say we'll have the attacked by increasing order, right? So I say if A0 equals B0, then we'll have the defense in a decreasing order. So it will have integer compare B1, A1. Otherwise, we're going to have integer compare A0, B0, right? So we have this kind of sort. Then we are going to have a count, right? Count equals 0. We have a defense right max equals 0, right? Because we know this kind of value is greater or equal to 1. So let's put on this one as 0 as initial value. So we are going to have iterator from the right to left. For each I equals, let's get to this length out. I equals for this. That means for I equals n minus 1, I greater or equal to 0, I plus. And we'll say current character, we have the property property equals what is I, right? So we'll compare this one's defense value. If property 1, this is defense value. If this one is strict less than the right one, that means on the right, at least there is a character stronger than this. So we'll have defense right max. Then we just have count plus else. That is if our property one, that is a defense value is greater than the right max, then we just update defense right max equals 1, right? And then in the end, we just return count. In -1 properties are is 3. Sorry, should be this. Doing like this way, we have a sorting here. The sorting will be an n log n time complexity. Assume the length is a, and there is no extra space.